Hi friends, it's time for us to do another math lesson. This one is Module 6, Lesson 8. You're going to be using the problem set and it starts on page 59. Another page that I want to call your attention to is this template page on page 63. I actually made some copies of this one so that I could make some visuals for myself. You can use that one if you want to. Now you're going to be on the problem set. In order to help you know what to do, I'm going to be using this page. It's the homework page. It's set up the exact same way, but the numbers are a little bit different so that I can teach you how to do things, and then you'll go back onto your page and do them with different numbers rather than me just giving you the answers. As you look at your math papers, right over here, we're going to be looking at 220 100ths. Well, 220 100ths, I have tenths right here, and I want to know how much are 220 100ths. Well, what is that in terms of tenths? Well, I know that 220 100ths, if I go across here, I can do 1, 2, 3. There's 5 spaces there, and 1, 2, 3. So I've turned that into 100th. And I can do the same thing on all of these. 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So what I have right here is one whole 200. So 200 gives me one whole one here. That's 100. One whole one here. That's 200. And then it gives me two little ones right here. This one and this one. That's 220 100ths. Well, that's the same as saying 1, 2. I'm going to stop for just a minute and stop the bells ringing. I have a dog. Sorry about that, friends. So we're looking at, we have 220 100ths. And how do we change that into tenths? Well, I know that I can make the columns going down right here, and there are 10 of those. So this is equivalent to 10 tenths. This one is equivalent to 10 tenths. And this one is equivalent to 2 tenths. So if I add those up, I'm going to have 10, 22. And I have 22 tenths. Well, 22 tenths is equivalent to 2 wholes, so 2 ones, and 2 tenths. And that number is equivalent to 2.2. That's how they all go together, from fractions to whole numbers to decimals. So in the space below, you can take a minute to explain how you got your answers when we get there. So now let's look at how we're going to have place value discs to represent decompositions. So we have 3 ones, and we want to know how many tenths that's going to be equal to. So we've got 3 ones right here, 1, 2, 3. And I know that, here's my decimal point, and I know that each one of those ones is going to be equivalent to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I know that this one is going to be equivalent to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I know that this one is going to be equivalent to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all of these ones can be put back and decomposed into tenths. And so actually 3 ones is equivalent to 10, 20, 30 tenths. If I have 3 tenths, 1, 2, 3, I can convert the tenths into hundreds by doing the exact same thing. I know that it's built on tenths. So I can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So These hundredths, now I have 10, 20, 30 hundredths. And 30 hundredths is the same as saying 3/10. They are equivalent numbers. So as you're looking at those, you might say, well, why do I have to do that? I just know that 3 times 10 is tenths. The reason that it is you might be there, but somebody else might need to see what the picture and the math is behind and where we're trying to go with this. And if your parents are listening and trying to help you, we want to know what is the math behind the rules. So as we grew up a while ago, we were taught the rules. And the rules are great, but what we want you to know is what's behind the rules. What happened to make those rules? Right? 3 times 10, because each one of these is 10, would be 30/10. But rather than just saying take these 3 and multiply it by 10, I want you to visually see what that rule was. So here is 2 and 3/10. Well, 2 ones, 1, 2 ones, and 3/10. 1, 2, 3. Now I know that these 3/10, I'm going to try to figure out how many tenths. So I actually started to move these over to the hundreds and then realized, hey, wait a minute. These are tenths and these are tenths. So I don't need to change these ones. So I'm going to keep those 3 there. But these 3, right, these ones are going to have to be changed into tenths. And so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm using different colors so that way I don't get confused. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you have some colored pencils or some markers, it might be a way for you to also look at them. So now, if I have 2 ones and 3/10, 2 ones and 3/10, how many tenths is that? You're right. It's 23/10. So the same would be done over here. If I have 3/10, 1, 2, 3, and 3 hundredths, 1, 2, 3, and be careful that you're reading the words and lining them up to the heading where they go on the place value chart. Because if you were to put the 3 here and the 3 here, you would end up with very different answers. 3 hundredths I'm going to leave alone because I'm going to answer in hundredths. The 3/10, I'm going to have to go this way. So I'm going to take this tenth and I'm going to change it into 10 100ths. Same with this one. And look at what I have now. How many hundredths do I have now? And if you said 33 100ths, 3/10, and 3 hundredths, you would be correct. Isn't that interesting that 3/10 and 3 hundredths would be 33 hundredths? 2/10 and 2 ones and 2 ones and 3/10 would be 23/10. This is the format that you will use to answer these questions on your problem set. Let's look at the next page. The next page, we're going to be looking at decomposing the units to represent a number as tenths up here and as hundredths right here. So now what we're going to be doing is you can still use this format, and that's why I mentioned that you might want to make a copy of this so that you could use it to make a picture for yourself. I'm going to set this one just aside here so that we can kind of see. I took this as a copy of page 63. It's a template in your math books, and I just made a couple of copies of it so that I could use it with you guys. But if you don't want to make a couple copies, another good option would just be to take a blank piece of paper, use the headings, and then write new lines down it so that you can use it like that. Another way to make that work. Okay, so here we have decomposing. So 1 is equal to how many tenths? Well, I know actually that this is one whole, and I know that it's broken up into tenths. So how many tenths are in one whole? Well, 1 is equivalent to 10 tenths. So if 1 is equivalent to 10 tenths, then what is 1 and 3/10? What is that equivalent to in tenths? Well, I can do the same thing. I'm going to leave the tenths alone, the 3. But this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many tenths is 1.3 equivalent to? Well, how many tenths is it equivalent to? It's equivalent to 13 tenths. 10 plus 3 more, 13 tenths. Now I have 10 tenths. I'm going to draw a little line right here. Or maybe I will use my own idea and grab another one of these. And I'm going to see how many are 10 tenths. So if you don't want to use a printer, you don't have a printer, you can actually make use of the graph they gave you with the tens, ones, tenths, and hundreds. Just add another piece of paper right on top of it. Extend your line so that you can use it multiple times. So 10.3, so I have 10 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tenths. And I have, whoops, did you see what I just did? I said I had 10 tenths, which is actually 100. So I really don't have 10 tenths. So if you make a mistake, you can start over. You can actually go like this and extend that one. No big deal. Reframe your thinking and move on. So I have 1 10. I don't have any ones. And I have 3 tenths. 1, 2, 3. So I know that 10, I'm going to need to take that 10 and make it over into 10 ones right here. Now I could draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now each one of these ones is going to have to move over here because I know I have 10 of them. So I decided that, I don't really know that I want to draw all of those, but I do have some pens that I could use. So I'm going to take this one and I'm going to make a 10 right there. And I'm going to use this one and make another 10. I'm going to use this one and make another 10. So I've got 1, 2, 3, 1, 2, 3. And I've got another 10 right here. Another 10 right here. Notice how I'm marking them off because I want to keep it straight. Another 10 right there. Another 10 right there. If you run out of colors, you can repeat some colors. It's just more that we keep going and making it consistent here. These are all, imagine that I've taken each one of these and I'm making 10 dots here. So now I have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and 1, 2, 3. I have 103 tenths. So in answer to this question, 10 tenths, or 10 and 3 tenths, is equivalent to 103 tenths. Now your numbers are going to be slightly different on your problem set. You're going to be using 1, 1.7, and 10.7, but the system for figuring out the answers is going to be exactly the same. So now let's look at, so that's what we did here. We have 2 tenths, and 2 tenths would be, 2 would be equivalent to 20 tenths. Remember, 2 would be equivalent to 1, 2. 20 tenths, and then you would continue on the same way. And if you have questions, that's what you would reach out to me for on office hours, or to Mrs. Sisney on office hours as we go through this. Okay, so let's looking at the hundreds. 1, well, remember that if I were to take this one and divide it this way, because I've already got 10 this way, and go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Now I've got 100. So 1 is equivalent to 100 hundredths, right? Take a minute and see if you can use the place value grid to change 1 and 3 hundredths, 1 and 3 tenths, excuse me. So look up here. We'll go ahead and do it up here. So you have 1 and there's 3 tenths. So how many hundredths do we have in 1 and 3 tenths? How many hundredths is that? Take a minute and see if you can figure that one out. Okay, so as I look at it, I have 100 right here, 100 hundredths right here, and I have 30 hundredths right there. So one way I could figure out 1.3 or 1 and 3/10 is how many hundreds, is I could just add 100 plus 30 and end up with 130 100ths, which is like saying 1.3. So I have 130 100ths, or I can look over here and say, well, I have 100, I have 1, and I have 3/10. Each of these 3/10, 1 is still going to stay 1, but each of these 3/10, this becomes, just like we did on this one, 1 becomes 10 over here. So I know that 1 here is going to become 10 tenths, and each of those tenths is going to become 100 over here, because this would be 10 tenths times 10 tenths, so it would be 100 over here. Not sure if you can see that in the screen. And each of these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I just didn't want to draw an extra 100, so I'm going to start with 100 and 10, 20, 30. I have 130. I got this 100 by taking this one and making 10 sets of 10 here. And each of those 10s became 10 over here. So 10, 1 times 10 is 10, and 10 times 10 is 100. So that's how I got that one. Again, going back to each one of the steps along the way. Now, if I have 10 100ths, 10.3 100ths, well, how is that going to translate into hundreds? That would mean I would have 10 of these. So I know that I would have 10 of these full ones, which 10 of these is exactly like 100. So it would be 10 times 100, which would be 1,000. So 10, this would be 1,000. And I would have 100, I would have 30 still of my hundreds, because I already have hundreds right there. So 30 and 1,000, and I would add those together and I would have 1,030 hundreds. Kind of mind-blowing, isn't it? You would do the same thing on this side, following the same process. Then we're going to look at the bottom here, where it has a decimal, a mixed number where it's the whole number plus the fractional unit, what it would be like in tenths, and what it would be like in hundreds. So as you're looking at that, let's do a couple of those. Let's look at 5.3. 5.3 would be the same as saying 5 and 3/10. 5 and 3/10 is the same as saying 53/10. And I know that because I could use 1, 2, 3, 4, 5, and 3 more tenths. So I know that I have 10, 20, 30, 40, 50, 3/10 using the picture there, or using the place value. I would have 53/10, and it would be 53/10 would be what it would look like in a fraction. Now, what would that be times 10? Well, it would be 530 hundredths. And it would be 530 hundredths when it looks like a fraction. That's what it would be looking like. And it doesn't matter when you're looking at the whole numbers, you're going to be multiplying 5 times 10, 53. Because remember, this is 10 times 10, 10 tenths plus 10 tenths plus 10 tenths plus 10 tenths plus 10 tenths. That's 5 10 tenths. That's 10, 20, 30, 40, 50 plus 3 tenths, 53 tenths. So this is the same thing. 68, you're going to multiply 68 times 10 tenths. So it would be 680 plus 5. So it would be 68 and 5 tenths. So this is going to be 68 10 tenths. If I added all 68 of those 10 tenths, it would be like saying 68 times 10, which is 680. 680 plus 5 is 685 tenths. It would also, I forgot to write the word, but it would be 685 tenths. And over here, it would be multiply by 10 again, and it would be 6,850 one-hundredths, or 6,850 and the word hundredths. And all you're doing on this chart is looking at the different ways of writing the same decimal, the same fraction in an equivalent way. It's a fancy way with bigger numbers of going all the way back to when we had our equivalent fractions like this. We're making equivalent fractions, and if I have 1/2 times 2, I can make an equivalent fraction. But in this case, you're multiplying them by 10 and by 10 again. By 10 to get tenths, and then multiply the tenths by tenths to get hundreds. Give it a shot. If you have questions, you're going to ask Mrs. Sisney and me. This is a big lesson, but it's a foundational lesson for where we're going forward. All right, guys.